All right, this is 5-6, the remainder and factor theorems. Going to keep this short and sweet for us today. We're going to apply the remainder theorem to evaluate polynomials and use the factor theorem to determine whether a binomial is a factor of a polynomial. Okay, so the remainder theorem, all that it says, it's like a shortcut to evaluate functions. I didn't give you the mathematical definition of the remainder theorem, but if you really want it, you can go look it up. It's going to be super fun. Actually, you know what? We got some time. Let's just do that. Let's look up the remainder theorem. Isn't that fun? In algebra, the polynomial remainder theorem states that when a polynomial is divided by a linear polynomial x minus a, the remainder of that division will be equivalent to f of a. Isn't that fun? All this is saying, guys, is that when you do synthetic division, the remainder is going to be the value that we want. Okay, so if I asked you before this video, if I asked you before this lesson to find f of 4 given this polynomial, what would you do? You would just take 4 and plug it in everywhere, right? Oops, why did I put a 2 there? I don't know. Right, you put 4 here, you put 4 here, you put 4 here, you put a 2 there, and you'd evaluate, okay? And you get a number. This is just saying that we can take 4, do synthetic division, right? So let's set it up. 3, -2, we need a placeholder 0, 5, and then 2. I'm going to write my little hash mark there to separate my remainder from everything else. Bring down your 3, multiply outside, add inside, right? Multiply outside, add inside. Multiply outside, add inside. Multiply outside, this is a big number, we get 660, meaning that we get 662 here for our remainder. So f of 4 is equal to 662. Okay, so if you plugged in this whole thing, you would get 662. So it's just an alternative way to evaluate polynomials. Okay. Oh, did I miss something? I guess I'm missing stuff in my notes. I'm sorry, guys. There are 2 examples in your notes. So let me see if I can insert a blank page real quick. All right, so I want you to take the polynomial 3x cubed minus 6x squared plus x minus 11, and it wants you to find f of 3, okay? Go ahead and try this. Pause the video. All right, set up your synthetic division. Bring down your 3, multiply outside, add inside to get your remainder of 19, meaning that f of 3 equals 19. Okay. And then the last one, our polynomial is 4x to the 5th plus 2x cubed plus x squared minus 1, and it wants us to find f of -1. And set this one up. All right, put a -1 out there. We need a placeholder 0 here because we're missing our x to the 4th term. Okay, we're also missing an x term, so we're going to need another placeholder here in just a second. 2, 1, 0. If you cannot remember synthetic division, there is a video on it somewhere else in Unit 5. Okay, 5.2, I believe, is that section. Multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. So -6 is f of -1. Okay, -6 is f of -1. This is not a super helpful concept, which is why we're not going to spend a ton of time on it, but it does exist. Okay, other part of this lesson, factor theorem. So again, we're working with synthetic division. The premise is that if whatever we're dividing by is a factor, then the remainder is going to be 0, right? So use the factor theorem to determine whether x minus 5 is a factor of this polynomial. Okay, so if we take x minus 5, set it equal to 0, that corresponds to x equaling 5. So we want to set up our synthetic division with a 5 outside, a positive 5. Okay, and then 1, -7, 7, 15, and then same old, right? Bring down, multiply outside, add inside. And look at that, we get 0 for our remainder, so we would say, yes, this is a factor. Okay, second part of this, for the polynomial x to the third minus 7x squared plus 4x plus 12, 2 is a 0. Okay, express the polynomial as a product of linear factors. So since 2 is a 0, we're going to take that 2. We're going to use synthetic division. Okay, before I get too ahead of myself, right, let's talk about big picture of this question for a second, right? This is like saying when we take this polynomial and when we divide it by x minus 2, right? So if we were to do long division like that, we're going to get a remainder of 0. That's what it means, okay? What they want us to do is go ahead and do this division, figure out what the quotient's going to be, and then factor the quotient. Okay, they want us to divide, find the quotient, and then factor the quotient. Okay, bring down our 1, multiply, keep going. Okay, we get that remainder of 0 just like they said we would, right? And then this is our constant. This is our x term. This is our x squared term. So we can rewrite this polynomial using that linear factor, right? X minus 2. And then this quotient that we just got, x squared minus 5x minus 6, okay? And so this is equivalent, right? This is equivalent to the original one that we just got, x cubed minus 7x squared plus 4x plus 12, okay? And then it wants a product of linear factors, so we got to keep going, all right? We don't have a linear factor here. We have a quadratic factor. It's got that degree of 2. So we're just going to look at this quadratic piece and factor it. Okay, what can we factor x squared minus 5x minus 6 into? We can factor it into x minus 6, x plus 1. And that's your answer. That's it. Okay, that is all for 5-6. Take a look at your practice. Let me know what questions you have.